Check, check. Hey guys, I'm gonna start by introducing ourselves. I'm Gabriel, and I'm more or less a software guy. And recently I discovered that I'm good at breaking things up. So back in Romania, I'm known as the public transportation hacker. I hacked the public transportation system in Bucharest a while back. And after the disclosure of the vulnerability and all that, I moved my sights towards more fruitful domains such as car hacking. So
Gabriel stopped taking the bus for the car. Myself or him? Check, check. Okay. All right. So as for myself, my name is Stefan. I've been doing security for a little bit more than 10 years now. I was mostly involved in malware research and cybercrime and cyber espionage, but now in the last 2 years, by the way, doing malware research, people think it's an activity that looks like this. So it's like you're sitting in front of your computer being very bored. But in reality, it's something that feels like this. It feels like you're in a corrida fighting a bull. And I guess everyone here who's interested in security or discovering vulnerabilities can feel the same thing. You can feel the adrenaline rush when you're discovering a new exploit or something that wasn't known before. Just a little bit of shameless self-promotion. So if you're on Twitter, make sure to follow us, especially Gabriel, because he really needs some followers.
I'm not a bot. I'm for real.
His account looks like it's a fake account, so we need to make it look more real. But yeah, Twitter is a great thing for security people. It's like a big chat room where you choose who you want to be in that chat room. So yeah. We're going to talk about smart car security today. And the reason why we are very interested in this is because we live nowadays in a world that is becoming more and more connected, and in which essentially every car we drive nowadays is a computer running on 4 wheels. So if computers can get hacked, cars can also get hacked. And the reason why I think this is very important is because of the possible consequences. So if your computer gets hacked, somebody infects it, then maybe you don't care that much. You just reformat the operating system, the hard drive, you reinstall the operating system, and your computer is like new. But with cars, then human lives can be at stake, because we're moving slowly into a world in which cars would be fully autonomous. So these are the 6 levels of smart car, of autonomous cars. Level 0 is there's no automation, and level 5, the last one, is the world in which you can just read your newspaper and the cars operate fully by themselves. So right now we're somewhere at level, I think, between 2 and 3. So most of our cars already have some automated functions, but you still need a driver in the back of the wheel and to make sure that everything happens correctly. So in order to get to this level 5 of full autonomy when talking about cars, engineers in the automotive industry are essentially adding more and more connections to the cars, more and more sensors, more and more communication protocols. Cars will have to communicate with one another, cars will have to communicate with the streets, with the roads, and so on and so forth. And I don't know about you, but soon we're gonna have real car botnets, I think. So that's why we became interested in smart car security. Now, of course, a big incident that I'm sure all of you know about from 2015 was when Charlie Miller and Mr. Valasak, when they hacked a Jeep that a journalist from Wired was driving on a highway. So this was a very impressive hack, because essentially they managed to find a vulnerability that was remotely exploitable through the 3G interface of the car. So each car had a SIM card that was connected to 3G. So they theoretically, if they would scan the whole IP address space of AT&T and identify each Jeep that was connected to the network, they could have run their exploit on all of the cars. So of course, after their stunt, Jeep had to recall 400,000 cars, if I remember right. So that's a huge impact. I mean, for an auto manufacturer, if you have to recall, hundreds of thousands of cars, that means a big loss and a big drop in your shares on the stock exchange. So yeah, I'm gonna pass the mic to Gabriel to tell you how we started this project.
So besides the fact that I couldn't travel freely with the bus, I like to tinker a lot with all of the technology that falls into my hands. So as soon as I got my car, I just started trolling forums and looking all around the internet for ways to, I don't know, make it different. You know, there are many like it, but this one is mine. So I just need to change its background, or remove certain safety features inside the car so I could play with the touchscreen while driving and all that. And interestingly enough, this brought me to like these really hardcore hobby forums in which people try to reverse engineer debugging features that the initial manufacturer left. And somebody managed to get SSH access onto the car. Now, what they were mostly using was a script that would be run by somebody in service, and it would execute a bash file that you would leave on that USB stick, and then you would have access all around your system. So after basically using their work to get an SSH shell inside the board, I started digging down and see what's going on inside my car. So again, looking around, it's got a pretty known processor that's developed for embedded application, a random Unix distribution. It's got the GPS module soldered on board. Now, for older cars, they used to sell that module separately, but the new ones only basically license your maps, the maps that they want to sell to you, and leave the GPS soldered in order to basically make the upgrade as seamless as possible. And this is going to be useful later when we go to the forensics part. 1 gig of RAM, a Wi-Fi module, and the USB thingy that I was telling you about. Now, coming from a dumb car, this looks a lot. I mean, for 2014, this was exactly the same kind of power that you would have, I don't know, on a mid-core phone with Android that was about, I don't know, 1 or 2 years older or something like that. So we have a car, its infotainment system, SSH that we can use to get into the car, and that's when we started the whole forensics part. Now, right off the bat, you have access to certain tools that were left by the developers to display debug message and stuff like that. The same kind of tools that were used to get SSH onto it. So we abused that script. We disabled IP tables because it looks like SSH access was enabled across the board initially. So now you had to have a hardware device in order to disable IP tables and have the ports open. We ran the SSH daemon, and we got in. It had a random default password, really easy. I mean, all of this was basically information that was leaked from the manufacturer to the guys, to the enthusiasts on the forum. And running around, I found a few interesting files that had the SQL extension, which were basically full dumps of the data of my database of phone contacts, of phone numbers, call history. Yeah, I should be calling my girlfriend less. It's and the most worrying part was that we also found this binary blob. For whoever is not in Romania, those were our street addresses together with the numbers of the street. Those were the most visited locations that I inputted into the car's GPS system. So all that was there in plain text. And after digging a little bit and correlating everything together a bit more, I even discovered that it held a history of your favorite routes in order to suggest them while you are driving or selecting a new destination from where you are. So that's a major information leak that you can do with just an USB.
By the way, I just want to make this clear. So this is the first part of our project, which was the forensics part. In this part, we tried to put ourselves in the skin of, let's say, an attacker that once he gets full access to the car's onboard computer, the question is what kind of data can he extract about ourselves. And I think that this is actually an area of the forensics business that will be growing more and more in the future, because law enforcement organizations around the world, they are already doing digital forensics when they have suspects that they arrest, and they do the forensics on their computers, they do the forensics on their phones, and I'm sure that in the future they will also do forensics on smart cars or other smart devices, because there's real evidence that can be extracted from there.
And this can even be exploited by a malicious actor. Just think about getting a rental car, for example, and you would basically be able to pull all of the info of all of the phones and the drivers that have connected to those cars in the past. And there are some extra information on the side that we didn't get the chance to fully analyze it. And we found stuff like voice profile, vehicle status info, like how hard you would brake and how fast would you accelerate, and even a directory listing for your phone. And this isn't really that dangerous per se, but when you consider that if somebody puts a stick inside your USB port of your car and can discover that you use Telegram, because Telegram saves its attachments in a folder, and then folder gets indexed because it has media on it by your car, even though you didn't actually request that. It gets kind of scary. There's a lot of metadata that you can gather just by analyzing this kind of info.
Yeah, like you think you're using an encrypted chat app, but then the file names of the attachments that you received are just available there, and your car is seeing it, and then it's saving it forever in a non-secure way, and it's not deleting the information after you disconnect your phone from the Bluetooth. So yeah, the feeling that we got after doing this forensics thing and on the car's infotainment system was the fact that this is probably made by very good engineers, but engineers that never had to design a system that was connected. And if you think about it historically, infotainment systems of cars, they were separate devices, like you couldn't connect to it. You could maybe connect to radio and listen to the radio, or put it in a cassette or a CD to play it, but not actually have internet on it, not have Bluetooth, not have USB. So at one point, probably someone in management, came to the engineering team and said, hey, we need to connect our infotainment systems. We need to put them in the cloud, or something like that. So they quickly had to find some solutions and to implement them. And this is why we think that that these things are so vulnerable. And basically, what we're noticing is that whenever auto industry develops a new, connected system, they start thinking about security, but they only think about security in the last phase of the project, just before the project is shipped. And we would like to live in a world in which automakers would start the project with security. So security at the bottom of the pyramid, and then build everything on top of an already secure platform or framework with, secure development practices.
And it's really interesting because security comes up there at one point. You can see it, but it's only physical security, not the actual safety of the data about you that you store inside the computer on 4 wheels.
So yeah, moving on to the second part of our project. So the first part was to try to understand what can be done with that computer. The second part was to actually do something with that computer, to make it do something which it shouldn't do, something that the engineers didn't think of. So we essentially created a proof of concept script. It's a bash script. It's nothing very complicated, but it's a script that that lives off the land. It takes advantage of binaries and tools that were left there by the developers. So essentially, we deploy it through the same feature that granted us SSH access in the beginning. So a USB thumb drive that is inserted into the USB. We then use cron to keep the script alive. And what the script does is essentially 2 things. First of all, it constantly looks for open Wi-Fi networks that are around the car, and it plots this data on a log file together with the GPS coordinates that we're taking directly from the GPS module. And we're plotting all of these data inside the log file. And then whenever we find an open Wi-Fi in the range of the car, we just connect to that Wi-Fi and upload the data to a server that we own. Essentially, creating a scenario, in which you ward drive without a laptop. So you just drive your car around the city, and the car automatically plots open Wi-Fi data. So it looks kind of like this. So I had to explain the script to our managers, and they only understand pictures. But yeah, you can see this is the area where Gabriel lives in Bucharest, and those are the open Wi-Fi networks around it. So yeah. This is a security conference, and I know that security people, they love to see demos. So our initial plan was to bring the car here in front of you. But we talked with the organizers, and they said that that would be a little bit complicated to get the car here. But that's why Gabriel, before coming here, I hope the video works. He took the car for a drive around his block, and we added a little feature to our script that would show a pop-up message. Display a message on the screen every time the car sees an open Wi-Fi network. Of course, we did it just for the demo, but in a real case scenario in which an attacker would like to monitor all of your movements around the city, essentially installing a GPS tracker in your car, of course you wouldn't see anything on the screen. So really sorry for the bumpy roads. We don't have the best roads in Romania. But yeah, this is our demo, so time to applause. Thank you.
But anyway, after this whole ordeal, we started bumping ideas around and thinking what could happen next. And while presenting the whole web vehicle weaponization scenario and installing a backdoor for GPS access and so on and so forth to a journalist, he told me, but could you put ransomware on it? And I guess, yes, yeah, this might be at some point. Imagine that you're investing about, I don't know, 20,000, 40,000 euros into a vehicle that you own, well, then paying a few $100 in order to use your infotainment system isn't that far-fetched. I mean, for your laptop, you just format everything and call it a day. Maybe you even have some backups, but you can't actually do anything. At least on the car that I have, if you have it bricked. Factory reset isn't actually factory reset. It only reverts certain files to a certain state. But if you install something like something blocking the spawning of the process, because, by the way, we were running as root. So the GUI was running as root. There was no sandbox in between processes, nothing like that.
No hardening, no separate
Nothing.
Usernames for different components. It was just, it seemed to us like the system was designed as a development system, not as a production system. So the engineers just assumed that nobody will have access to the system because it's an air-gapped thing. But then they had to add all this connectivity to it, and it essentially opened it up to the real world. And I think this is the big problem with Internet of Things nowadays, because there's usually developers of embedded devices that worked on devices that were never connected to the internet, and now all of a sudden we're connecting them more and more. So the discussion with that journalist got us thinking, what scenarios can happen into the future, because maybe ransomware, I mean, it's a good example for, TV, for them to illustrate getting a virus on your car, but in reality, maybe more dangerous things will happen than your car not starting up in the morning.
Yeah, so we kind of started investigating into how we can exploit the infotainment system in its communication with the other subsystems around the car. And we discovered the CAN bus. We started snooping around, and the car has a really neat feature with its smart city brake assist or something like that, in which it brakes if it detects something in front of you. And we wanted to basically spoof the messages from the sensors that were going up on the CAN. But then a really neat idea came into my mind. What if we attack it from the other side? So what if we decide to actually jam the said sensors? And my car has, at least for this system, has a ultrasonic set of rangers in its bumpers in the back, and a LiDAR in the front, just for evaluating the distance. And I started again looking through forums and I don't know, just trying to find any kind of open source intel that I can discover. And it looks like people were actually trying to jam these kinds of radars in robot contests, and were actually discussing the legality of doing something like it within the context of that that contest. So it's completely doable. At least the ultrasonic jammers are completely doable, and the car can't really provide any meaningful information for about the distance when it comes to its to the nearest obstacle. So this creates an actual usability problem that can be exploited from a certain distance. And some people in China decided to take this one step further and to spoof the radar signals that were coming from a Tesla. And they actually did it with a piece of hardware from Keysight, a signal generator, after that a mixer, and they managed to go up to the 60 gigahertz range, in which they could confuse the sensors enough in order to not let the car start from its position, because it had no telemetry.
And by the way, so this radio equipment that they use, the Keysight device that generates radio waves, it's a pretty expensive piece of equipment. So it costs around $100,000. But the message that we want to send here is that these kind of devices, like RF devices, and you probably know this better, they are becoming more and more cheap, right? I mean, you can probably do more or less the same thing with a Blade RF, which is just a couple of $100 instead of some tens of thousands, even $100,000. And actually, this is one of the messages that we're trying to send to security researchers when we go to conferences, that, you know, car hacking doesn't have to be something very fancy. It doesn't have to be something very expensive. With just a couple of $100 or euros, you can just get a Raspberry Pi, a Hack RF, or whatever radio board, and you can start messing around with all of the sensors that the cars have, like reversing sensors or tire pressure sensors. Like all of these things, they transmit data to the car's onboard computer, and most of this data is not sanitized. So you'd be surprised in what kind of features of modern cars you might be able to find some remote execution.
And even for the whole radar hack before, even if right now it costs a couple of $100,000, if you want to actually build a setup for actively spoofing radar, that's what was said about radio amateurs a couple of years ago. It would cost a lot just to start mixing and sending radio waves by yourself. And with the advent of SDR, everybody has started joining in and contributing, and we have GNU Radio that is able to do a lot. So the entry level is going down as time passes, the entry barrier.
So yeah. Oh, and by the way, this project of ours, it took essentially a weekend if you put on all the hours that we worked. So it took us a couple of hours to be able to get access, and a few more hours to create the proof of concept. And then, so it's not something terribly complicated, but it's something that the automotive industry definitely is overlooking right now. So I guess we're quite okay with the time. I'm gonna talk a little bit about the conclusions, because we have 3 main conclusions to draw from this project, and then we're gonna have a little bit of time for Q&A. So the first thing that we realized after this whole story is that our privacy is definitely threatened. And of course, this is not necessarily new in the world of computers and social networks and mobile phones. But when you're thinking about a car, you're not necessarily thinking about the privacy consequences that there are. And the reason why I'm thinking this is very important is because, especially in Europe and in North America, smart car sharing programs are becoming more and more popular. So instead of everybody just owning a car, there's some cars that we own together and we share them together. Also, we're doing quite a lot of travel for business, so from time to time we get to rent cars. And of course, when you rent a car and you have to drive 100 miles, then you probably want to connect your phone with a Bluetooth just to listen to your favorite music. And not many people realize that when they connect their phone to the car, then the car will get access to so much personal information that will never get deleted from that system. So I think that this is a big problem that our modern world is facing. At the same time, there's the thing that I was telling you about connecting these devices more and more. So of course, technology always evolves, but I like to look at this evolution as a double-edged sword. At the same time, we have all the good things, the benefits from living in a connected world, but at the same time, we need to think of also the new doors that we are opening for attackers or malicious actors to profit or to abuse our technology in some way or another. And of course, the human nature is in such a way that we will always want smart things, but I'm just thinking that, you know, we should think about security as well, not just about features. And last but not least, I just want to end this on a positive note, because if you look at the history of the automotive industry, they have a very good track record when it comes to actually implementing security features. I'm thinking of physical security features. And this is, of course, it's a long history. It mostly happened because of regulation, and regulation mostly happened because there were victims. But right now we live in a world in which whenever you buy a new car, that car will come pre-equipped by default with all of the security features that you need, like ABS for braking, or ESP for stabilizing the car, or the basic seatbelt or airbags that will protect you in case of a crash. And we have crash tests, and we give ratings to cars in depending on how they perform in crash tests. And I'm not seeing any reason why the industry wouldn't do the same thing with cybersecurity. So we need some official tests, some official organizations that will test if the security of the cars are good enough or not, give them ratings, and then consumers should make an educated decision based on all of this data. And I'm thinking that the industry is ignoring cybersecurity because so far there were no real consequences, there were no really dangerous things because of a cyber attack. But I think that the day in which, you know, human life would be lost or threatened because of a cyber attack in autonomous cars is coming. So we're counting.
It's all fun and games until somebody loses an eye. So
yeah. So just before we end, a little bit more piece of bragging, so to say, because we've been doing this presentation at all sorts of conferences around the world, mostly security conferences, so that we can meet like-minded people that are also interested in hardware and car hacking. And we were very, you know, pleasantly surprised by the media coverage that our little project got, because, you know, publications such as Motherboard or Decipher or The Register, they wrote about it, and these are very good, you know, InfoSec publications. But the reason why we are even more proud was when Forbes contacted us to do an exclusive interview about this thing, so that appeared on Forbes.com, and we were happy because we saw this discussion is moving out of the bubble of the security people and more into the, let's say, mainstream area. And then we had a couple of interviews with two car magazines, Car Buzz and Drive Mag. And that was actually what made us really happy, because we realized that our message is getting into the area of automotive people, people passionate about cars. Because in reality, the reality is that security people, they live in a bubble, like we live in a bubble, and we all agree with each other that everything can be hacked. We all agree with each other that there's no such thing as 100% security. But then these messages, they just stay inside the security community. So this is why we think that events such as hardwear.io, where security people can meet hardware people and all sorts of engineers can meet each other, are very important, because I think security will become more and more important part of IT and the world that we live in. So yeah, thank you very much for paying attention, and if there's any questions, that's what we're here for. Thanks.
He just did some great Hardware.io promotion. Thank you. So who wants to start with the first question?
Okay, first, in 3GPP, in next generation 5G cellular networks, they are now in release 16 talking about V2V and V2X standards. There is a lot of study on it, and what is appearing is that there is a lot of attention that the autonomous car, most of the in dense urban area, will be not be done in the car because it's not have enough computer ability and resources and cooling system and so on. It will be done in data center that will be on the fifth and fourth generation, that will be very low latency connection to that area of controlling and get back the driving instruction and so on. First, everybody can now go to this standardization learning and so on and give security reason and change the following release if it will be closed and change it. This is the time. So everybody here can now change or get the security reason where to put it and what to do.
It's not a question, right?
Yes,
it's more of a call to action.
Addition to what you...
Yeah, thank you very much for the comment.
Yeah, well, I haven't seen that much action when it comes to V2V and V2X, to be honest, at security conferences. I've seen it at auto shows, at tech shows and stuff, but nothing really, I don't know, security people oriented. Give them to some guy at a hacking IoT village or something like that. So we'll have to wait for that.
Another question?
Means everything was clear.
I guess. Well, thank you very much.
Thank you so much.